between different kinds of units that are treated as the same, though strictly speaking they aren't. And so in astronomy, for example, wavelength and frequency often refer to the same thing, but they're completely different units. But there's a conversion term that's employed. So, you know, you can, in the AstroPy units, you can say, I treat these as equivalent, and it knows how to deal with converting one to the other. That's not something I've seen in many unit packages. So anyway, and so, you know, you can take that and combine 2 unit quantities, and you get what you'd expect out of it. Avoiding copies, William went into this a little bit, and I will show this again as an inline case where we're just making some random data, and what we are doing is essentially making a mask quantity that's an integer. These are 1D arrays, and these 2 data sets are sharing the same mask, and then it writes it to the file. And what you're going to see here is this data, you know, has an inline set of data here, and then the mask has this anchor identifying this as something that will be used somewhere else. And if you see for the second data set, the mask here just says, you know, star ID 001, which means look for the, you know, where that's defined, and you know, create it identically. In the Python library, when these are loaded, it's the same object that they both point to the same object. So if you loaded it in and changed, you know, one of the values in the array, they both see it because they're actually sharing the same object. And that's just to illustrate. I'm printing the ID of the 2 masks, and it's the same, you know, it's the same object internally. So at this point, we're gonna do some examples. So in order to do this first one, you'd have to execute the cell in the notebook to get the tag demo file to do editing on. And so the idea is to add something to it, add another scalar quantity. You're going to have to label it with the appropriate tag, you know, the way you saw it in that file, the way it is already. So that's something you have to get right in order for that machinery to work. And that's a little bit tedious. Normally somebody would not be doing this by hand editing, but at least this will show you, you know, how the structure all works. The second is an exercise 2 file, and the idea is to find the shared items and all objects in there that aren't primitive using the info thing and list them. A little bit of the odd thing, you know, it doesn't say these are shared items. What you'll see in the info method is that they're listed as recursive references when it sees something that's already seen before. And this last one is to define a common multi-line description for all dicts that have widget in their attribute name. There's a reason you can't, I'll explain it now. We're using the YAML library's ability to identify shared objects intrinsically. And it works for things that are not primitive items, but it doesn't work for strings. So it would not be able to, it will not bother to try and identify common strings for a whole set of reasons. So if you want to share a common string, you got to put it in a list or something like that, and then it'll show up as a shared item. So anyway, put that in and, do that in Python, save it, and then look at it with the editor and see that everything behaves the way you think it ought to. And after this session, when you get into the real heavy-duty stuff of making extensions, so that'll be another level higher. Let's see, 15 minutes? Yeah. And if you have any questions, please ask. I'll just go over some simple examples. Everybody can do this in their own particular way. Since I'm not going to jump into an editor to do this, I had a modified version of tag dump, and I'm going to print just the contents without using ASDF at all, and then use the info command to show the contents. So I added a temperature, and you can see, it gives the units as degrees C, the value of 37.0. Ignore the warning there. And this is what the info shows. By default, the info is truncated, the number of rows it will normally show. So for very large metadata content, you'll want to use this max rows to extend the thing. And here you see at the bottom, it shows temperature as a quantity. When the shape is empty, it's basically a scalar, and then it's a double precision floating point. Any questions about that particular case? The tedium here is, of course, making sure you got all these tags right and setting it up as a quantity if you're hand editing it. So the second one was to open this file, take a look at it. And you would to do a couple things. I'll ignore all this previous stuff and look for anything that isn't sort of a primitive thing, lists, dictionaries, things like that. You can see the widget properties here is related to something else, this one here. And the properties too is not the same. And launch time is a time object. So those are the particular items that, and now I'm just printing these particular things. Yeah, the one shows what type the launch time is and the value. So the first is the type of the launch time, which is an ASCII time core time object, and the second one actually prints a value, which is close to the ISO notation for time. And then this is checking to see whether or not these widget properties are actually identical. It's referencing the first one, referencing the second, and just testing whether the two are actually identical, and they are. And for the last, come up with a description. Here I've made a list of 2 strings. It could just be a multi-line string as well. And then I go and attach description to this widget properties 1 item, and then to choices 2 widget properties 2, I attach the same description. I only have to do this once here because it's a shared item, and for the other one I have to add the same description. And then I write this to this modified file, open it, and print it out. And so we see if we in fact see these strings, and under launch control, you can see the description here has that anchor, and it has those two strings in this list. And then for the other two, you see references. See, this one's the shared item that was there before for the actual launch properties. That's 001. And the string item, the list of strings, is 002, and that is referenced in the second properties. Since this widget properties one is already shared, there's no need to duplicate it again. Does that sort of make sense? Dave, what was that?
Oh, sorry. The anchors in the file, do they, because it's like ID 001, does it mean there's a limit of like 1,000?
I've never tried going above 1,000, so I don't think so. I think they probably could handle more than that, but I'd have to. Yeah, it's a good question.
I don't think there's a limit. I think it's just that's
Yeah.
sort of padding, so that if you start exceeding 1,000, then it would just rewrite all the anchors.
I think so, yeah. But I probably would like to check that just to be sure.
We should probably have access to that.
If you have that many, it's an interesting case. Any other questions? Okay, on that, I'll have William come up and show how one writes extensions. And depending how much time we have, we might even be able to get into the entry points part of it.
Yeah.
That adds a little bit more interest.
All right, let's talk more deeply about these extension objects and how to write them. So obviously we've talked a lot about extensibility and how it would be great for people to be able to write their own things and have them work well. So the question is how do you actually create these things? They're kind of mystical magic. And I'll preface all of this by saying these steps that I'm going to take you through, you would typically do them kind of all together. Like you'd set them side by side and kind of work on them as a unit rather than you do it in the order that I'm specifying here. It's just that we're kind of we're constrained to a linear ordering here. So let's talk about how to do it. So let's say create an example object. I'm going to create, say this is my example object here. It's just an ellipse defined by a semi-major and semi-minor axis. Nothing too special about it. I'm mostly just defining it as a data class so that I can call assert equals and prove to you that they're the same as far as an equals operator. So how do we add these in? So ASDF needs two things in order for this to work, essentially. It needs a tag that's defined within its resource schema architecture so that within the ASDF file, that object can be called out by itself so that it knows to operate the machinery. Then it needs a converter, which is the machinery itself to handle the to and from. So it hasn't really been talked about very much, but we have these schemas, but we really haven't talked about how they relate to tags specifically. So typically what you would do is you'd create a schema, and then we would then associate that schema with a tag and another schema document that we would call the manifest. Now, that the reason why the schemas are distinct from the tags is so that you can typically reuse them, right? Like, for example, sine and cosine models would have essentially the same parameterization, only the associated function that you're using is just different, right? You'd have an amplitude and a frequency and etc., but you just call a sine and a cosine function differently. So you can essentially reuse the same schema, you just tag it with a different name. So that's one example of it. You can also just use schemas. Although JSON schema language doesn't have inheritance, you can kind of pseudo do inheritance a little bit with them in this way. And then the converter is just a Python object that has some methods and it specifies what tags it covers, and it specifies what objects, and it has all the magic Python code to make it work. So let's first start talking about this tag. So like I said, it's identifying that subtree that will be turned into a given Python object. So to do to create this, as I've alluded to, you need to create the schema for the tag, the schema or schemas that define what you want to go into the tag. And then you need to create an association between that tag and those schemas. So let's talk about creating the schema. Nadia already talked a little bit about it, so I'm just going to kind of gloss over this and point out important details. First, as she mentioned, these two lines here are kind of what define it as this particular YAML file as a schema. We're talking about the draft. And typically what you would have is you'd have an ID, and that ID can be used to reference this schema within JSON schema and other schemas through the ref, which hopefully I'll get to later. As a point of contention, we're going to be talking about IDs and URIs. They don't have to be the same, but if you want to stay sane and you're developing things, you do want to keep them the same. So the URI is how ASDF tracks the document that this is stored as, and the ID is how JSON schema can reference it between schemas. And while you can set them as different things, and we don't prevent you from setting them as different things, in my experience, if you try to do that, you will quickly run into headaches. And so here's just, the rest of it is just defining that object. It's an object, it has two numbers, the semi-major and the semi-minor, and they're required because I didn't make either one of them optional. So before we talk about adding this as a package, I'm going to talk about how you would test it from the point of view of doing things dynamically, and how you would kind of work all the details out without having to create a Python package and start modifying your packaging stuff and all of that. So we're going to be using this method called add resource mapping, which is going to be on the ASDF configuration. And basically, all it does is it maps a URI to the content of a resource. right? And when ASDF loads everything, it will lazy load and it'll start adding resources as need be, and will all have a URI, and it will read the YAML content and dump it into that and cache it. Now, this config object, you can play around with the ASDF config if you want. It has some useful things, especially for debugging. If you're running into weird things, I encourage you to look at it. But for now, you can modify your current configuration, and until ASDF reloads, your configuration will stay the same, and it is a context manager, so you can temporarily modify it as well. Now, let's just look at the schema. So we provide a method called check schema, which checks that it is a valid schema for ASDF. This would just fail if it wasn't. So once you've written a schema, you can always just load the schema, and you can check it. Note that check schema also works on just the text of the schema. This load schema is literally loading the text out of ASDF from that mapping. You can then check if something that you expect to be a valid tree, so the actual dictionary that you would get out of the YAML, check that validates against the schema. With this schema validate, you just specify the schema, and so you can see it. This I required both semi-major and semi-minor. So if I miss one, it does say validation error. And then you scroll down, semi-minor is a required property. Note that for all this checking and validating and all of that, ASDF provides a PyTest plugin that you can point at the directory that contains all of your schemas, and it will automatically generate tests to check them as valid, or check them, check the schemas, and then you can add examples in there in a special way, and it will call the validate between the content and the schema. So try to generate a schema and add it to ASDF dynamically for this object. And hint, you can basically just copy and paste and change a couple of words. Okay. So if we look, let me just copy all this. Okay, so let's start with modifying this schema. First, I needed to modify the URI from being about ellipse to being about rectangle. I'll call it rectangle. And then I just need to change the names of my properties. Technically, I didn't have to, but it would just you'd start to confuse yourself. So you might as well. I can just add it now to the ASDF config as a resource, and then I can perform a couple of checks. Any questions? So now let's get into the tag. So basically, the tags are just defined in a manifest, which is defining the version of the extension that you're doing. So like ASDF standard is itself an extension to ASDF, and it has a manifest that lists all the tags that it's providing. So like I think the current working standard is 1.6 that's under revision. So as we've changed tags in it, we update until we decide that version is finalized. We'll just keep updating the tags and that. So like version 1.5, it's basically a list of tags, and then the URI, a tag URI and a schema URI, right? So the tag URI will be what you use in that colon, or that tag colon, put this tag URI in to reference it inside a schema, and then the schema URI is what we register the schema in the resources with, and it's a special schema in some sense. And so kind of just looking at it, so here the manifest, I have to define a URI for that, which is for this schema itself, which is the manifest. And then you can do an extension URI. So this URI is how later the extension code will point and look at this. So we'll grab this reference locator to grab that, because you could say that your extension works for multiple manifests, so you can use a thing and say versioning and all of that. And then finally, I define my tag itself. Here's my tag. Notice that all of these, we do the ASDF colon stuff. In the past, as it was HTTP, which was confusing to things, and so we just decided that we were going to own that. And so here's the extension itself. We have our ID. We have the extension URI. You can add a title and description if you want. And the main thing is you have a key tags, and then it's just a list of tag URI, schema URI. You can put more information under this if you want, like you could put a title, a description if you want, but you could also just keep it simple. We have some tooling now that you can have essentially the tag URI and the list of schema URIs, and it will make sure that it satisfies all of those schemas. So as just for context. And this is just another schema, so you just add it like you would add anything else. As a resource, you just take its URI and you point it at the content of this manifest schema. Any questions? Awesome. And you can check that it works. There's not a really great thing to validate it against other than its own content, but its own content should validate against itself. So now let's add a tag for your rectangle to this manifest. It should be as simple as adding another entry and then re-adding it. And when you add a resource, you can copy over it by pointing at the same URI. As I alluded to, basically, in this case, all you have to do is you could just copy all of the stuff we had before. You just need to create a tag for rectangle and then add it and an association to your URI, to your schema, which we've already added in, and we can check it just like we did. Are there any questions? Yes.
So to the definition of the converter here, there is a bit of boilerplate, right? You have already specified that the L should be semi-minor and semi-major, and now you have to rewrite these all over again in multiple places. So would you think that from a certain data class, you'd be able to sort of automate more of this?
This is something that I've been exploring, but this existed before I came in. A lot of what this stems from is that our archive was specifying a file, and then we were kind of basically generating you would be given a scheme and you'd be generating the object that you want to store all of that from the file that was handed to you. I agree it would be nice to automate it. There's a lot of boilerplate here that I'm trying to simplify. I think that eventually something like Pydantic could be used to kind of smooth all of this out. The question is with that is getting it to plug into the rest of the schema architecture that already exists that we've already predefined. And in fact, you should probably be able to generate converters on the fly too, if you're clever. But so the converter. So really, if you have an existing Python object that you're trying to add to ASDF, you're really developing the converter and the schemas, and the tag is just on top of the schemas, really defining the converter and the schema at the same time, assuming you already have an object. You're basically writing things down twice in just two different ways. And what this converter typically provides is it inherits from this abstract type that ASDF provides, and you need to define two methods, the to YAML tree and the from YAML tree. And they do exactly what you'd think. The to YAML tree takes in your object and outputs the subtree. The from YAML tree takes that subtree under the tag and outputs your object. And it only needs to worry about when the tree is converted to and from, you only have to care about the things at the level of your object. So you can spit out other objects within this that are convertible by other converters. So you don't have to worry about converting it all the way down. You just have to do it at the level of your object. And it also, you need to define two variables, tags, which is the list of tag URIs that you are expecting that this converter to work for, and then the types, which are pointing at the types of the objects that this converter will convert on the tree. So basically what happens is when reading from a file, it will encounter a tag and it will search all of the converters for one that lists that tag in its tags variable and do it. And unfortunately, if you define two converters that are trying to convert the same tag, it will just pick the first one that it encounters. And what ASDF does is when it loads everything, it sorts them so they're alphabetized. So you could, if you really wanted yours to be first, just stick a bunch of A's in front of the name, and it should work. But there's talk about having manipulation of that, but currently it just picks whatever it encounters first. Same thing on types. When you put an object that is an intrinsic in the tree, when it's trying to write it to ASDF, they'll look at the type, say it's not an intrinsic, and then it will go and try and search for a converter, and it will do it through the types until it gets to it. That types can be a string instead of just an import, and that will save you some speed, but I'll just put it directly in there. So for our ellipse, you can see all I have to do is I just need to read the two properties, set them in the tree, and then the reverse, I just set them like this. Typically, you have the object, the tag, and the context. Context isn't used much. This is used for really, really complicated advanced things. And then the tag, so we'll always, when it's converting to a YAML tree, it will identify the tag that it's converting to first, because you can have multiple supported tags, which we'll get into later. So it'll pass that tag in, and then the object itself. Similarly, you get the subtree here under node. You get the tag that subtree was read from, and you also get the context. So it's basically the ASDF config. Any questions? So this is what a converter looks like, at least at a basic level. So try to do this for a rectangle. Again, this is just a lot of boilerplate. That kind of does it, which is why, trying to embed all of these things in extensions and making them modular is nice. So let's take a look at this the converter for rectangle. You can see it's just, for the simplicity of these examples, just go and find and change all of the things from what they were for the ellipse to what they were for the rectangle. The main point is generating a to and a from. And finally, we can construct the actual extension. There are two ways to do this. The first is this manifest extension from URI, which is you point it at the actual URI that stores your extension, and then list all the converters that you want to be associated with that. And this does some magic. It reads what it does is it reads that manifest, it looks up the extension URI, it puts things in the right place, it generates lists of tags that are associated, and a bunch of other stuff. And so then you can, instead of doing an add resource, we just add the extension. If you want more control, you can add the extension directly by creating an extension object, which is useful when you're trying to start playing with the extension behavior a little bit, which we've had to do for some things. And this, you actually subclass the extension, and then you have to set the extension URI, you have to list all your converters, and then you have to list all the tags that are covered by all of the converters. So basically, the union of all of those tag lists, as if they were sets, yes.
Why must you specify those?
Well, this thing does all that for you. This is just if you wanted to have more control, you can start messing with the routines that this thing provides, and when you start doing that, you have to specify a list. This is so that the search is faster. It looks for the extension first. Okay, so this will just overwrite the previous extension. It'll actually just put it on the list of extensions that it does. It'll put it at the bottom. So I won't activate that. In either case, I recommend doing it automatically if you can. If not, you can do what you want with the other one. So this is just a test of it. Like, look, now I've created an ellipse object and I've actually written it to an ASDF file, and it was in a fairly seamless way, as long as I don't restart the this current interactive session, so that the config gets wiped out, and we can look and see here. Here's our ellipse, and here's that tag that we specified at the beginning, and it wrote it out. And indeed, if you look at the rest of this, I actually associated these two and found that they were equal. And if we check the ID, I'm going to assert if ellipse is not equal and it didn't fail, so we know that they're actually two different distinct objects It hasn't somehow copied it from the void. They're both the same. Now, how are we doing on time? Because I want to make sure we can get to the further.
We have 15 minutes left.
Okay.
So there's plenty of time for the last segment.
Okay.
So
I will make you guys create the converter. It's going to be identical, or add an extension for your rectangle converter. It's going to be identical up to changing a couple of things. And now let's just talk quickly about entry points, because this is how you get all of this machinery to then talk to ASDF. So to create an entry point, you have to do two things. You really have to do three. You have to make sure that all of those resource files actually make it into your package, so it's put into the wheel and everything. And that's a sometimes very irritating thing to do. But Setup Tools provides stuff to do that. The main thing is that you have to do for ASDF to work once those are in there. So you have to create an entry point to add the resources to ASDF, and then create another entry point to add the extensions. So the resources will be added and then the extensions. So the way your entry point would look like in a setup.config is, here's your entry points. There can be others, but let's just pretend you're just adding this one. So ASDF honors this entry point called asdif.resource mappings. And what it expects is a name for your package, and then that pointing at a function that it can just call without any arguments that returns a list of all of the resource mappings. So there's going to be a lot of them potentially, but that's what it is. And what this language looks like is, here's the name of your package, here's the name of the module, and then here is the function inside the module. And then that's just what I've decided to call this package's resources for ASDF. Any questions? Now that, if I could, I'll go ahead and write, you would go ahead and write your files to, or write your schemas to files. That will do it. And what I'm doing here is I'm creating a directory structure that mimics this whole structure back up here at the beginning. Keep going. Here, this URI, I'm creating a directory structure that kind of mimics it. So this schema/rectangle, I'm mimicking down here with this. Everything's in resources/schemas. And the reason for this is we provide this directory resource mapping thing, which crawls a series of directories and builds the URIs to add the files. And so we can add a directory resource mapping on the schema root with this prefix. This is the prefix for that. And it will add all of those things. Similarly, it will add all those. So it'll generate all of those mappings between that and the content. It'll just provide a file name in this case. And then this thing will magic out loading the YAML for ASDF. And notice it's just returning a list of these. Any questions? Now, the entry point works the same way, only extensions are under asdif.extensions. And operates the same way. It's expecting the same thing. It's expecting a list of those extension objects that we created at the end. So you can see this manifest extension from URI, you just put in the URI for that manifest and then the converters. Are there any questions? Because I want to get to the next tutorial, because I think there's some good stuff in there, I want to quickly skip down in this next example, which is just adding some stuff to an existing, to extending an object. And I want to talk about a converter in this case. So suppose you want to create a converter that converts more than one tag or more than one type, or, you know, and they don't have to be a one-to-one mapping. We have examples of that aren't. What additional thing does this thing have to, what additional steps do we have to take? Mainly, we have to add another method called select tag, which takes in the object, and it'll pass a list of tags from above, and it returns the tag for that object will be covered under. So in this case, we want our new rotated ellipse to give the rotated ellipse tag. Otherwise, we want it to be just the regular ellipse tag. It should never hit this value error, but I have a hard time just leaving it so it returns none, and then things would really break. And so this select tag will handle that. And what happens is when it's converting to the YAML tree, it will run select tag first on the object, get the tag, and pass that in as the tag argument here. And then when it's doing the from YAML tree, you'll get the tag out of the tree along with the subtree that is associated with it. And so then you can condition on that to switch between converters. Are there any questions? All right. Next tutorial.
I should add, in doing all this boilerplate stuff, most of the work is getting the first one done.
Right.
And adding, you know, all the other objects you want to do development for is fairly straightforward.
And part of the reason why there's a lot of boilerplate and it's not super automated is most of the objects that were initially intended for ASDF already existed, so they weren't like data classes. They were blown out models that you had objects that you had to like know a lot about to know what you needed to add to the tree, and required a lot of thought and development to just figure out what you needed to do to round trip it correctly. So.
And there are variations. I should extend a little bit. So, for example, for the telescope data, a lot of the metadata doesn't convert to complex objects. They're basically dictionaries for information purposes. And so some of the framework around that is to provide a nicer interface so that in accessing, you don't have to use a dictionary notation. You can use an attribute. You know, you could say meta dot exposure dot exposure time or something like that, and get a nicer way of accessing all that, and yet have it all checked with the schemas and whatnot. And have all the nodes typed as you might expect for routines that need to access that information. So it all depends on exactly how you want to use the objects that you're looking at. So there could be variations on what it needs. Of course, the example he's showing, the objects are simple, but in general, the objects have a lot of other functionality. Like, well, for an ellipse, you compute the area or something like that, which isn't all that complicated, but usually the kinds of things you're serializing have a lot more functionality associated with them. Anyway, I'm going to finish this last section on a variety of things, some odds and ends, and also where we think we're going with this in the near term. So anyway, you've seen a little bit of all this already, but I thought I'd show another example of serializing analytical models. A little bit about, let's see, I think some of this is repetitive. I'll see what it comes to. So here, in this example, we're using an AstroPy model that's a polynomial model, third degree, and setting the coefficients, in this case to be relatively simple, and plotting out what it looks like. So, okay, nothing particularly fancy there. And writing it out in ASDF, and just comparing it to the what we had written before. So essentially, it's the same model. Now we're going to do a compound model. This is, I think, where the power of this becomes a little more apparent. Is we are going to create a sum of the poly model we just created with a sinusoid, given the amplitude and frequency and phase shown there. And this notation indicates that we are feeding the result into the input of a Gaussian model. So this is a little bit of an odd model. I mean, it's not picked to be particularly physical or anything like that. So you can chain functions together so that the output of one function goes into another function. And so what you get looks a little odd. So that we're going to write that out as an ASDF file, and because some of these are arrays, we're putting them in line, and we'll talk a little bit more about that. So you're seeing a lot of stuff that indicate that the terminology here is transform, mostly because it had to do with the coordinate transformations we're talking about, but these are basically just functional models. And there's a lot of machinery that goes along with these models. They can have inverses, they can have bounding boxes, all sorts of information that can be useful in fitting and doing other things. So here, this is the first thing you're seeing is that this is a forward transformation, and that it consists of that we're going to add some models together. And so you see the polynomial model is defined in this first, it's a list of models, and the second one is assigned 1D, and it defines what the inputs and outputs are, and that is in turn fed into this Gaussian 1D model. So that's how it's stored. And so you can see, for example, in the Gaussian, it has information about where you should not try to compute the value. I think this is one of the special things about this kind of format, is that it can handle much more flexible structures than just simply sets of arrays and groups of arrays and things like that. It's you can do a lot more in the YAML construction. Now, I touched on this before a little bit. If you want to manipulate how to store arrays, whether you want them to be binary or in YAML itself, you can use this all array storage inline. That means everything will be done this way. And you don't always want that in particular. So, as you can see here, there are two arrays. Both of them are, this is a two-dimensional array, and this one is a one-dimensional array, and they're all inserted in text. You can specify that some of them are internal and some of them are inline. The internal means it'll be written as a binary block. There are other options here too. You can specify external, meaning it's in another file, as an example, but I haven't shown that here. So I'm trying a different technique here to avoid reading the binary. I've specifically put the length of the data that it's a kludge. So you could see in this case, in the case of A, it has a source, which means it's binary. It's stored in a binary block, but for B, it's stored as inline. And again, this there's another feature that we haven't been able to quite implement because it was causing trouble with our past usage of data on the telescopes. Setting a threshold for when you want one to be external would be nice. That says if it's more than 100 elements or something like that, write it internally, because the advantage of doing that's not great. Or if it's larger than that, write it as binary. That's been coded, but we have not made it available yet, I believe, right? Similar kinds of things can be done with compression. There are two kinds that are internally supported right now. These are the options, zlib and bzp2. So the you can say write to, and then there's this all array compression, and specify what kind you want. That's the simplest way to do it. For example, I created a very large array here, and and then when you read back the length of the content, you'll see that it's much smaller than that because they're all zeros. Right, the length of the file is only 1,600 bytes, but the array size when you read it in is considered to be much larger. And similar to the what we did with inline, you can specify what you want with individual arrays. So in this case, B is set up to be compressed BZP2, and so that's, if you want different things done with different arrays, you can do that. So again, that's I'm going to talk a little bit where we like to see things going. Before I do that, I think I'd like to say a little bit about, we talk arrays, but in some sense I'd like to see it generalized. We could store almost anything in a binary block, and you can do that now in a more explicit way. I mean, we had somebody requested that they wanted to store a PDF in there. Well, as long as you could represent the PDF as binary, you could store it as a binary array, recover it, and then treat it as PDF. But I wonder if it wouldn't be nice to support some sort of like almost MIME-like thing where we had a standard set of types of things that people in software commonly support. Let's say Python would know what to do with these various things and generate that. But that's sort of just things for the possible extensions. I'm going to talk mostly about things that are on our horizon for, that obviously we have to give priority to things that the missions need. And, but, since one of the new missions, the Roman telescope, is intended to be done at cloud processing, enabling efficient use of cloud resources is one of the things that is becoming a high priority. So one of the issues that's been raised is using something like FS-spec, probably layered on XAR, maybe Dask. We haven't thought this through entirely. Also very important because we're beginning to deal with very large data sets where we need to support chunking. And so that almost certainly would be layered on XAR. And it'd be nice to incorporate that, as one of the native formats supported under XAR. And to do that means improving how we're managing blocks right now. And we see a variety of ways of doing it because there are at least two kinds of paradigms for doing chunking. One is keeping everything in the same file. For certain uses, that's nice, and it could be that every chunk goes in its own block, and that makes one kind of usage better. But then there's another case where we put all the block, essentially all the blocks in separate files, and that has many use cases as well. So we see at least two kinds of what's going on here.
Sideways.
What's that?
Sideways.
Oh, side. Wait a second. I mean, I think I was. What? And there's a need for more flexible compression. Some compression techniques require extra parameters, for example, and a way of encoding that. So we've had requests to do BLOS kind of compression and this, and that requires a different approach than what we used, what I just showed. Some of that's already, there's already a mechanism for doing some of that stuff, and I think it needs a little more development. More of a wish is, at the moment, is see some sort of independent language support. I always think that, if you want to show that it's really language neutral, you really need an independent implementation to show you're being honest. Something that makes, a lot of people making interpreting schemas a little easier. I mean, for lots of scientists, engineers, and things like that. When they first look at a schema, it's not all that easy for them to, understand it completely. And so some distillation of how they appear is nice. Also, an easy way to retrieve things from the schemas, like if, say you wanted the description of, very lengthy description of some parameter in your file, and that's in the schema, and you'd like to say, I'd like to get it out there. For example, the info command right now gets the comments that it sees on the line from the schemas. So it goes in, which are the titles. So it actually goes and retrieves the schemas to populate the info display, so that, that's one of the FITS had a space for comments on its cards. It was how much space you had left over after you used everything else out of the 80 characters. But that was treated as part of the data. Well, YAML has no real comments. They're not considered permanent in any way. They're they disappear when you read the files in. So that functionality is being supplied through the schemas primarily. And that's the way we see how these things do. And other things at the Institute, for example, we've merged our schemas with what they need for the archive, or how they figure out where they get the data from. And so we're actually using the schemas jointly with other projects. I mean, other groups in the Institute. So they use the schema to know, oh, this item goes into this catalog entry in the database. And this item is created from our telemetry stream, and we get it from this source of information. And that way we stay in sync with what they're doing and how our pipelines actually work. So that's a case of where the schemas can actually be shared with other kinds of uses other than just for the ASDF file. But anyway, so things to make interpreting schemas and extracting information from schemas easier is something I think is very useful. Supporting custom validators is something that we would like to do as well. So those are some of the things that we're looking at doing in the near term. The one that requires the most resources is, alternate language support. So I'm not quite sure, where we'll get the resources for that. But if we can get other people interested, that would be great. At that point, I think I have questions, but, if you really want an exercise, you could satisfy that for us and write a C or C++ library for ASDF and send it to us. You'll get extra points for that. So on that note, I'll just open up for questions, and if anybody else wants, a further explanation of some of the things we've gone over or what we didn't go over, this is a good time to ask. Yeah.
So I take it from the list of future things that compression is not a thing that you can implement a custom through an extension.
You can.
You can,
Write a
yeah.
custom compressor
Okay.
and add it to an extension.
Okay.
But it requires it to basically just take in the data and spit it out and not know anything, not have any other special thing. But yes, you can definitely write your own compressor.
Yeah. And we tried to make this, that every format has its drawbacks. And, I'd say in this case, the thing you'd want to avoid is putting a huge amount of stuff into YAML, because then you're limiting your performance and having to parse the YAML. But, usually, very often when that's the case, you can find some way of embedding that into binary, for example. Or even if you had nested YAML, you could imagine something where there's, you don't want to parse everything, and you just put, deeper down structures, YAML structures. You could do that. I'm not sure how. I haven't thought that through, but so that's obviously one of the big performance issues is doing that. Otherwise, I don't see, since the machinery for accessing the binary data is fairly flexible, and you could make different, you could extend things. It doesn't have to be an array. It could be something else. And you could be able to get at different things quite, I don't see any limit on binary performance and the intrinsic construction of these files. It's the YAML that I would worry about the most. And perhaps if you had 1,000 extensions, it might slow down things. But I think the current machinery, makes essentially dictionaries of tags to various things. Is that right?
Yeah.
Yeah, so there's some time in building all that. But once it's built, then retrieving the right converter and all that kind of stuff should go fairly quickly.
We're very careful to cache everything. One thing that I didn't really touch on too much when writing extensions is to have like reasonable performance, like importing AstroPy is actually pretty slow. So you want to defer all of your imports until you're inside actual methods, because otherwise what will happen is it'll get to the point where the extension is, and then it'll like import all of AstroPy or something, and that takes a couple of seconds. And so for the terminal performance, for ASDF tool, it reloads the session of ASDF every time you run that tool. So if it takes a couple of seconds to load one of your imports, that will be tacked on to everything when you're trying to do the command.
Yeah, but the extensions have been set up so that the imports aren't generally necessary until you actually.
Yeah, we tried to design them so you should only have to import at the last possible minute.
Right. Only if you're using it. So. Other questions? Song requests? All right, I guess if that's it, do you have any final words?
Yeah, I would like to ask you to use the post-it notes, write some, use the blue one to write recommendations for improving the tutorial, and the red one if you have something, if you particularly liked something in this tutorial, so we can get some feedback today. Also, we are hiring another ASDF developer. If you know someone who might be interested, I guess I'll post
Yeah.
a link to the posting in the tutorial channel.
The drawback at the moment is the institute requires you to live somewhat in the vicinity, that not necessarily in Maryland, but in neighboring states. And that's, we understand that that's a roadblock for some, but otherwise.
Also requires US citizenship or green card.
Green card, yeah. So,
Thank you for coming.
yeah, thank you. Yeah. What's that?
Like an API specific, like all your functions?
Yeah, the docs have a developer API.
Can I just do that? Because I was looking at.
Did we show the posters?
Show the what?
The posters.
Oh, yeah, okay. Let's see.
So there's a, also we should mention,
So this is the bottom.
I mean, this is the main repository for the library itself. There's one for the standard. I should say there's some tutorials that are more in depth on making extensions, somewhat more in depth, both dynamically and all that use somewhat more complicated examples. There's just not enough time to do that today. So that would be under tutorials. The ASDF standard talks about what the standard for the format is. And anything else? There's a read the docs both on the standard and ASDF itself.
Yeah.
And there's some developer docs that are trying to explain the
Yeah.
deep down internals.
You can show that to click on ASDF and read the docs. And then they're all the way at the bottom.
Developer API?
Yep.
Yeah. There's also some trying to explain how things actually behave when you read things in or write things out. in detail, more in a sense of, how a time series of how things actually behave. So, these developer overviews. So let me make this bigger. So that's where you'd find it. Any more? Okay, I guess we're done. If you don't have any things to fill out and send us,